speaking of such things, I just wanted to bring this up with you, right? Because we went a little bit philosophical astronomically on the show yesterday by accident, and it was because of this story in the BBC Science pages. Every star twinkling in the night sky plays host to at least one planet, a new study suggests. And that implies there are some 10 billion Earth-sized planets in our galaxy. They're talking about this technology, micro-lensing, where they use the gravity of a closer sort of heavenly body to magnify the sort of light coming from something further. Do you know? Is this ringing a bell?
Yeah.
And so this is what they're suggesting, though, isn't it? That the more they clean the lens with the Kepler and stuff like that, the better the sort of resolution or whatever, or the better the techniques, the more exoplanets they're finding. I just wanted to look into this, like what statistically what this means for the possibility of life in the galaxy or in the universe and things like that. Really, what do you think about it, Brian?
Well, I mean, the question was that we until very recently, 10 years ago, let's say, we only knew about one solar system. So in our solar system, we have rocky planets inside what's called the habitable zone, which means that you could have liquid water on the surface. So the temperature is between 0 and 100 degrees, roughly. And then you have these gas giant planets like Jupiter. But it wasn't known whether that was standard. That's the way, because solar systems all form in the same way, which they do roughly. Then do they all have rocky planets, or most of them? Do they all have gas giants? Well, now, as you said, we're finding that probably rocky planets and gas giants are orbiting around most stars.
Yeah.
And so then you have to look at the star itself and see if it's been stable. I mean, our star's been stable, so allowed Earth to remain habitable for over 3 billion years.
Yeah.
Right, 4 billion years. So that was the big question. Are we unusual, or are we just normal and average? And so it looks like we're pretty average, and most stars have all this assortment of planets. So, as you say, that means that there are probably hundreds of millions or billions of Earth-like planets out there. And so then the question is, if you've got the right conditions, if you've got water and rock and all those things next to each other, then do you get life?
Yeah.
And that's a big question now. And so the way that we can answer that, there are two ways. One is, which we're doing, is go to Mars. Mars is a zone. There is liquid water on Mars or under the surface. We know that. So it's very important to see if there's life on Mars.
Yeah.
But then also you can start looking at these planets. We're close to be able to look at the atmospheres of these planets. So as you said, when they cross in front of this star, you can look at the light from the star going through the atmosphere of the planet, and that allows you to measure what the atmosphere is made of.
Wow.
And one of the things we emphasise in Wonders of Life, which is fascinating, is that there would be no oxygen in the Earth's atmosphere at all if it wasn't for photosynthesis.
Yeah.
So it all comes from photosynthesis, which actually ultimately comes from water. So the oxygen in our atmosphere comes from photosynthetic plants ripping electrons out of water and leaving the oxygen as a byproduct. So if you see oxygen in the light of a star shining through an atmosphere of a planet, then you're pretty sure that there's photosynthesis going on.
That would be exciting, wouldn't it? So what we're saying is that in the next few years, as this technology gets better and better, there's more and more chance that one day we will train our telescope on some distant planet and we will see oxygen in the makeup of the atmosphere, and we'll think this could be the place.
If you see oxygen, I mean, we don't know, right? We don't know whether life is common or whether it's rare yet. I think most people I talk to now think it's probably common, simple life. By the way, photosynthesis is anything but simple.
No, exactly.
So if you see oxygen, a lot of oxygen in the atmosphere, you're pretty sure there's very complex life there. Yeah. But maybe it's interesting because we don't even know whether the way that photosynthesis happens on Earth is the only way it could be. It isn't. There's simpler versions that don't use water. They use hydrogen sulfide and things like that, and then they produce sulfur instead of oxygen. And they were the more primitive kinds of photosynthesis.
So it's that system.
We don't know.
I mean, we got onto much more detailed philosophical points yesterday. It sounds facetious, but I don't think it is. If, some of these aliens sort of systems become extremely complex, perhaps as complex as us, or even more like conscious like us, is it possible that they could share human characteristics like empathy, impatience? Do you think that aliens possibly queue for things? do they get itchy bottoms? You know what I mean, Brian? I'm being facetious, but at the same time, there's a philosophical point to that, isn't there? The idea that a very complex, could something like jealousy exist in the emotions of an alien?
Well, I mean, there are two interesting debates that have been had over the years about SETI, so the search for extraterrestrial intelligence. One way of doing that is to beam out radio messages, which Carl Sagan was always a fan of. He always, and the reason he emphasised this was a good idea is he thought that if you've got an intelligent civilization, then you've got to get beyond the phase of being idiots.
Yeah.
Right.
Yeah.
So you know that human characteristic of being aggressive.
Yeah.
And potentially, you know, destroying
self-destructive.
Things with nuclear weapons and all that stuff. He firmly believed that a civilization of intelligent beings would get past that. So they would have all those emotions, but to get to become spacefaring and be able to build spacecraft to go between the stars, you've got to get over it, which we have to. Right? We have to get over this nonsense. But Stephen Hawking has always said that he thought it was potentially dangerous because he thinks you can't read that into another intelligent civilization. So we should keep quiet, basically, because we might attract some nasty kind of Independence Day type aliens down. So it's a good debate about how much he projects human characteristics.
I love that idea that essentially it's just like being in a rowdy bar. You just keep your voice down because there's some nutters in here. It's
well,
that
that's
feel.
What I think Stephen Hawking thinks that's what the universe might be like.
Yeah, just like a rowdy bar full of nutters. Yeah, it doesn't bear thinking about. Well, listen, we love you. Thank you very much for joining us. Will you speak to us next week? Would you dare to do that?
Yep.
Absolutely.
I should try and speak to you early next week. We should talk about that, shouldn't we? Because I'm doing stargazing. So
well, that would be even better if you would speak to us. That's you heard it here first. That was a genuine promise from Professor Brian Cox to come on twice next week.